All right, from one of our previous lessons, we looked at how to find the derivative of one of these exponentials. And we know that derivative here would be the same exponential, in this case 2 to the x, times, though, the natural log of whatever that base number is. So it'd be 2 to the x times ln2. All right. What about this one? Well, what we're going to try to do is figure out what is the derivative of logs today. So if we have this y equals log base a of x, what's the derivative of that? Right now, we don't know what that would end up being. So what we're going to do, instead of using log form, let's change this to exponential form. You guys have done that previously. So in exponential form, this would be that x, the thing we're taking the log of, would equal the base of that log to the power of y. That's equivalent to the expression above. That we do know how to take the derivative of. So let's use implicit differentiation and find that derivative. Right side, super easy, it's just 1. Derivative of the left side, that's one of those exponentials that we just looked at. The derivative would be a to the y, because that's the derivative of the outside. The derivative, times ln a. But then since we're doing a derivative of y here, it'd have dy dx. Let's solve for that dy dx now. So our derivative dy dx would equal, we'd have to divide here, so 1 over a to the y ln a. And then usually our derivative is not in terms of y, if we have started with just x on this side. So the last thing we're going to do, we're going to try and get this back in terms of x, and we can do that because we know a to the y here is equal to x. So we're going to substitute that back in here for a to the y. So what we end up getting is that our derivative, either y prime or dy dx, however you want to list it, is equal to 1 over x natural log of a. So if you're doing a log, okay, in this case the derivative here is going to be this. To do derivative of any type of log, it's 1 over whatever you're taking the log of times the natural log of whatever this base number might be. So just kind of putting that out there again. Derivative of any log base a of x is 1 over whatever you're taking that log of times natural log of a. What happens if we put the natural number e in for the base? What happens to the derivative? Well, remember, if you are trying to find what's the derivative of log base e of x, we have another name for that. Remember, log base e, that means we're doing what's the derivative of natural log x. Log base e is always natural log. Well, using our derivative we found here, what that would be then would be 1 over whatever we're taking the log of, which is just x here, times natural log of whatever our base number is. When we're in natural log, our base number is e. So it'd be ln e. Well, we know something about ln e. Those are opposites of each other. Natural log of e is 1. And so this just cancels out because it equals 1. And so derivative of natural log ends up being 1 over x. So anytime you're doing what's the derivative of natural log? 1 over x. Let's try one here. Differentiate this logarithm. So first thing here, we want to take the derivative here. To do this one, it's going to be 1 over whatever we're taking the log of, in this case 2 plus sine x, times the natural log of whatever our base number is. So times natural log, here our base number is 10. However, we're not done here on this one. This one is chain rule because we're not taking log of x, we're taking log of all this other stuff. So all this would be the derivative of the outside, but when we're doing chain rule, we got to go do times the derivative of the inside. So what is the derivative of that stuff in parentheses? Well, derivative of 2 is 0, constant. Derivative of sine x is cosine x. So that would be our answer. Typically on these, they're going to combine these into one fraction rather than leaving them apart like this. So we could just put this like over 1 to combine it. So it'd be cosine x over this stuff. And that would be our derivative. So there's our derivative for that one.